Hi, my name is Alex Fleischman, and welcome to the video overview of the string rotation demonstration. Alright, so in this demonstration, one student will swing a mass attached to the end of a string in a circular motion. Let's review the equations needed for this demonstration. Students will need to know that the velocity of an object in rotational motion is equal to the circumference of the object's path divided by the period of the object's revolution. Also, that centripetal force is equal to mass times velocity squared divided by radius. Alright, let's talk about the problem. We need to find the net force exerted on our spinner's hands due to the centripetal motion of the hanging mass. So, what relationship can we make between the force exerted on our spinner's hand and the centripetal force exerted on the hanging mass? Well, we could state that the force on the hand is equal to the centripetal force of the hanging mass. Alright, let's begin our approach to this problem by stating what variables we need to solve for regarding the centripetal force acting on the hanging mass. Well, we need the mass, the velocity, and the radius of the circular motion of the hanging mass. So how can we find the mass of the hanging mass? Well, we can place the hanging mass on a scale. Now how can we find the radius of the mass's circular motion? That's simple. Use a meter stick to measure the length of the string. Alright, this is where things get a little tricky. How can we find the velocity at which the hanging mass travels? Let's begin by swinging the ball above our head until a constant velocity is reached. Next, you have to time how long it takes the ball to make a set number of revolutions. In our case, let's go with 5. Next, we must divide that revolution time by the number of revolutions, in our case 5. What you have just found is known as the period of the ball's revolution. Well, you might ask, what's the period? The period is how long it takes the ball to make one revolution. Next, we must calculate the circumference of the ball's path using the equation c equals 2 pi r. We find circumference because this is the amount of distance the ball covers in one revolution. Next, to find velocity, just divide the circumference by the period. This is the same as distance over time. Let's work through a simple problem. A student decides to swing a 5-gram mass over his head using a 0.7 meter rope. It takes the mass 2.3 seconds to make 4 revolutions. Calculate the velocity at which the ball travels. Well, our equation for velocity is distance over time. The distance the ball covers is the circumference, and the number of times it covers that distance is 1 time. That's the period. So how can we find circumference? Well, we use the equation 2 pi r. In our case, we can do 2 times pi times 0.7 meters, because the rope is 0.7 meters, and we get 4.4 meters as the circumference. Next, we need to find period. We do this by taking the time at which it takes to make a set number of revolutions divided by the number of revolutions. In our case, we take 2.3 seconds divided by 4 revolutions, and we get 0.6 seconds as our period. Next, to find velocity, we just take the circumference divided by the period. Our calculated value of velocity is 7.3 meters per second. Next, we have to calculate the centripetal force acting on the ball. Centripetal force is equal to the mass of the object times the velocity squared divided by the radius of the object's circular motion. Well, for our centripetal force, we get 0.4 newtons. Well, to return back to the final problem, we must calculate the force acting on the student's hand. Well, the force on the hand is actually equal to the force of the centripetal motion of the ball. Therefore, the force on the hand is equal to 0.4 newtons. This final slide shows a derivation of the force on the hand using only variables.